to Prof. Khairul and Azry. So today, our group will present about the graphical user interface, GUI and Simulink. So I would like to briefly introduce about the GUI. Graphical user interface is a visual way of interacting with a computer using items such as windows, icons, and menus. It is used by most modern operating system, and we decided to make a graphical user interface using the MATLAB, which is the password window.
Assalamualaikum and hello everyone. My name is Mohamad Irsyad bin Mohamad Azry. My magic number is 196199. So right now I will present to you about the graphical interface user, which is GUI. And first step, we have to open the quick start in the MATLAB. We got quick start in the MATLAB. So in this session, we can edit what we're gonna do in this the session in the blank page. So next. So step 2, we click the edit text and then we start doing the visual for the password window like this. We can also change the color and also the shape of the box from this edit text. Same as the previous step, we create a blank box for the user to enter the password like this. Next one is we click on the push button in the option here to click the login button. So next step, in the at the login box, we right click and then we click the callback so that we can change the code in the to do programming and edit the code as shown here. Next, so this is the code that we change. So this is the code that we change. And if the user enter the right password, the program will show the window of the right password. If the user enter the wrong password, the program will show the window of wrong password. So let's see how it works. So these are the password window. So user have to enter the password. If the password is wrong, and the wrong password will appear. Instead, if the password is right and the right password is appeared. So that's all from me. Thank you.
Assalamualaikum. My name is Mohamad Azry, Fariduddin and my magic number is 197855. Today I want to present about Simulink. Simulink is a graphical programming environment for modeling, simulating, and analyzing multi-dominance dynamic system. Its primary interface is a graphical block programming tools and a customizable set of block libraries. Okay, we start with the problem that we want to solve, which is create a vehicle powertrain model that can be reused for control development. So how to solve this solution? Use Simulink driveline to model the system within the Simulink environment. So we use MATLAB 2018 to solve this problem. So first step is at the command window, we type /sc_new. So it will pop up this new Simulink model. As you can see here, after we put the command on the command windows, so then So then we click on the Simulink library over the right top, on the left top, and we search for the engine. Okay, put the engine on the Simulink Windows. Okay, then right click on the block to adjust the parameter. From here, when we click the the engine, it will pop up the parameter that we can change. So about engine top, we just left it default, but we change the dynamics and the inertia, which is changed to specific inertia and initial velocity, and change to 0.2, and then we click apply. So next, after we put the engine, we insert mechanical rotational reference block to the engine and attach it to the engine. Then insert PS. PS is physical sensor, constant block. Double click it to change the parameter for total input of the engine. So if you want to make the total full pressing, you make it 1. But in this case, we just want to use 0.5. So we just push the throttle half. Okay. Then attach it to the engine. After that, insert top converter block and attach it to the engine for the output of the engine drivetrain, which is over here is a drivetrain. And then insert the inertia block for the inertia of drivetrain. Double click on the block to change the parameter. So in here, we change the inertia to 1, and over here is the unit for the inertia. Okay. Then insert as we want to make it a simple. We insert a simple gear block. Then double click on the block to change the parameter. So change the output shaft rotates to this one. Okay. Output shaft rotates into the same direction as input shaft, so that the vehicle will move forward. Okay, after we put the top converter and inertia and simple gear, then we insert differential. Differential is for the engine power transmit to the tire. So here is differential, and then attach it to the simple gear. After we insert the simple the differential, then we insert 2 tires for the engine to transmit power to the differential, and then differential will transmit the power to both of the tire. Then insert vehicle body block and attach it with 2 tire block. This one, as you can see here, is a parallel longitudinal. So but we can assume that some of vehicle is front wheel drive and some is rear wheel drive. So we assume this front or rear wheel drive and attach it to the vehicle body, and then we put PS Simulink converter and scope to the output, which is velocity. Then double click on the PS Simulink converter and insert the specific unit of output. In here, we want to use velocity as kilometer per hour. So then apply it. So our simulation is complete. Then if we want to run the simulation, click the run button over here, and then it will compile, and then we can see the result on the scope for the velocity. As you can see here is a graph of the velocity from the static vehicle and when it moves for the 10 seconds. So it based on the output physical sensor, physical constant that we put the engine. As this one we put just 0.5 constant. If we put 1, it will make the graph will be the time taken will be shorter. So that's all from me. Thank you.